The following content has been provided by RWTH Aachen University.
Welcome and good morning, everybody. Welcome to DIS1. We're going to jump into the whole topic of evaluation today. So how do you figure out that third step in the DIA cycle after you've come up with an idea, you've implemented some sort of prototype. Now you need to test it, right? You need to figure out whether the idea that you're following is actually what your users are requiring. And so this is what this class today is going to be about. These techniques keep coming back to us in our own research. When people write their thesis with us, they usually always have to evaluate what they develop to actually prove in some way that it works, that it has a certain quality. And so those techniques will be very useful to know about if you decide to do your thesis with our lab. But also, if you go into industry, evaluation of interfaces is a huge part of the business in HCI and in usability, just to see whether any crazy ideas that design and engineering team came up with actually work for the people that you're developing for. Before we jump into that today, we're going to take a quick look at what we talked about last time, which was prototyping, of course. First thing we were discussing briefly were prototypes based on paper. And I'd like to see if you guys can recall some of the prototypes, the paper prototyping techniques, or the types of paper prototypes that we talked about. I'll bring up my little participants list, so feel free to go ahead. Yeah, Aparna, go ahead.
I think there were two different types. One is like there's a paper and you have a couple of screenshots written down there, and you sort of tell make the user go through each screens. And the other one is something like a flip book where you actually make them go through the actions, and if they click on a button, the next page would now bring up the next screen. So
right, the storyboard-like one is really one where you could give it to somebody and they would know exactly how the sequence works, because there's only one way through it. With the flipboard, you have sort of the flip book, you have sort of a collection of screens, and you kind of drive the prototype more. That's right. And we got these to be a little bit more interactive using what kind of staple office supply? Thanks for spotlighting. Yep. So how did we get beyond the very plain ones? Balit, what do you think? What do you think was the technique to get the paper prototype to be a little bit more interactive, a little bit more modular?
I'm not sure, but I think we talked about post-its.
Exactly, right, yes.
Yeah, for radio buttons, I think was that.
Yeah, for lots of things, exactly. Radio buttons, menus, dialogues, windows, whole screens. So go back to that and take a look also at the videos that we have there as part of it, because paper prototyping with post-its is really quite flexible, and there are a couple interesting tricks of the trade to get to a fairly interactive prototype with very little work, just a couple scissors and a pencil and a couple of post-its. All right. Then we spoke about software prototypes, and software prototypes. We have a typo there, Ollie, that we can fix later. Software prototypes have a whole range of things, right? There was a whole bunch of different kinds of software prototypes. What were the simplest ones that you remember? When we're now moving from paper to the computer? Yeah, no, it's a whole week ago. Tejaswini, yeah, go ahead.
The simple screenshot ones where you design the UI it doesn't have any functionality, it's just the UI. like a photo. And
exactly. It's really a picture, and it
the
doesn't
horizontal prototype. Yeah.
Right. It doesn't do anything apart from showing you the screen. And then you kind of have, as the developer or the HCI person, you know, the interface designer, you have to kind of drive that prototype as well and kind of give people an idea of what they should be doing to move to the next screen. That's right. You know, those can get a little bit more advanced if you wanted to add a bit of interactivity. Maybe Sarah?
Yeah, there are the vertical ones, which are focusing on only very few functionalities, but those are implemented perfectly. So we can, yeah, show this.
Right. And that's actually this distinction of vertical and horizontal, right? Whether we've got the vertical one that drills deep into the functionality, actually puts some, you know, meat behind the surface of the interface in a particular area, or if we just, you know, which is probably more common, really mock up the interface as a whole and don't bother about implementing, because we really just want to understand that if the interface were to work like this, does that make sense? And for that, we don't need the whole, you know, coding effort behind the interface. Now, couple techniques for, so that was horizontal, vertical, and a couple maybe techniques and tools that we looked at to get a little bit more out of it than just a series of screenshots. You know, what kind of tools could you pull out today from your laptop to build a thin horizontal prototype, for example, that had a little bit more interactivity than just screenshots? I'm going to go with, what do you think, Jasper? Any ideas?
I thought about yeah, kind of mocked websites, so a bit functionality, but not really. So yeah, a quick prototype, not really the whole functionality, but just the menus and yeah.
And so that's the HTML, JavaScript kind of thing, where you can start building something that does a few things, but the function that you then trigger just return like a default value that works for your particular scenario, for example. Yeah, especially when you're building a web system, of course, that's a perfect way to go, because you're already in the technology that you're going to be deploying later on. Then more general, if it's not a website, or even if it is a website, I mean, I've done that for a website. We had a demo actually of a prototype for a website that wasn't done using web prototyping tools. Do you remember what that was?
It was in Keynote, so
yeah.
So yeah, just use the animations and the links in slides, and yeah.
Precisely. Yeah. So that's how you can build prototypes that move a little bit more interactively, that the user can actually maybe play around with by themselves, even, because now you don't need to drive the transition from one screen to the next, or from one state to the next. You don't need to drive basically the state machine that's behind it. It's ingrained in the prototype already, and that works with PowerPoint or any other kinds of, you know, Keynote animation apps and so on. We talked about a few more tools. We've covered the web now. There were two more things that we looked into. Three, actually, if you want to be precise. As you get more and more functionality into your prototype, what else could you be deploying for prototyping? Yeah, Fabian, go ahead.
If I remember correctly, there were Photoshop prototypes, so with different layers which you can click through, and you can actually show the functionality of what the buttons are doing by using good footage or good pictures to show what the buttons are doing.
Yeah, and there's some tricks like layer comps that will actually let you move through a whole sort of configuration of layers, visible and not visible, with one click, and that almost feels like, you know, a nonlinear prototyping toolkit then. And it's especially useful if you have something very non-standard. Like, remember our personal orchestra interface for conducting, that was nothing like a normal Office app. So it wouldn't have been useful to use a prototyping like a user interface builder, for example, to do that. Instead, we had the artist come up, the designer come up with Photoshop pictures, and we had him layer it in a way that we could step through the different interface phases automatically. All right, we had, so we got user interface builders. I just mentioned that for if you are building in a standard user interface environment, like you're building a Windows app, a standard Windows desktop app or a standard Mac desktop app or whatever, then usually you get pretty good support for creating a user interface visually. For example, with the user interface builder that's part of Xcode and macOS, you can mock up interfaces for macOS apps or for iOS apps that still don't do anything, but it's very quick to do, and they really look like the real thing. Right? They are using the final look of the user interface components. So that's good if you want to get to that higher level of polish that you want to get to later in your prototyping. And the other one that we haven't covered one or two others yet. Aparna, do you remember any others?
Yeah, I remember I think it was called MSD something, where it basically processes the audio and video. I remember the video we watched, it was a blue screen, and like the different audio settings were like shown how to set it up and all that. So
that's right. Yeah. So it's not MSD, it's not LSD, although it does let you see very colorful pictures if you use it right. It's Max MSP, right? That's an environment particularly for multimedia prototyping. And I showed this for three reasons. First of all, if you ever need to do prototyping in music, audio, video, live processing, interactive responses, art exhibits, any kind of that kind of thing, Max MSP is really good. Second reason why I showed that was it's an example that there are sometimes prototyping environments around that you may never have heard about, but that are really a perfect fit for your use case. And you should always keep your eyes open for these kinds of things. So don't try to prototype everything in Visual Basic just because that's the tool you happen to know, right? This may really be the wrong thing to do. And the third reason why I showed Max MSP was because it uses this flow-based programming approach, this visual graphic interconnection of nodes that data flows through. And that's a very interesting prototyping technique because it visualizes your program flow for you, or better, rather the data flow. It's not great for highly complex algorithmic problems, but it's very good for interdependencies and data being piped through different systems. So data flow-based programming, or FBP as people sometimes call it, is a very interesting metaphor in general, and a very interesting technique for coding that's very different from your traditional line-by-line coding. Just as an example for that, we just recently developed a system that lets you do electronics prototyping and embedded programming for Arduino and microcontrollers like that. And that uses actually flow-based programming as a metaphor, and it's a very good fit for the task, because an electronic circuit is very much like that. It's got little nodes that signals flow through. That's called Flowboard, if you guys want to look that up. And that covers the different kinds of tools that we had. And then leading to the question, when should we do a hardware prototype? When is that actually necessary? Yeah, Tejaswini.
So whenever your system requires some sort of physical interaction, or whenever you can't get your users to imagine the interface just through software, you can use a hardware prototype that could be done with like wood or cardboard. So
exactly, yeah. And anything you wanted to add, Jasper?
Yeah, I think every time you use a new kind of physical interface, like not a usual consumer device, then it's necessary to do that.
Yeah, right. Remember the mouse prototypes that Microsoft did for their mouse, right? The Microsoft mouse, they had all these like foam core models to figure out how it fits. It's just something you can't really compute or predict. You just need to do it and try it out with real people. One thing that I wanted to mention here is driving of the hardware prototype, we had a particular technique that we talked about when you had to run the prototype, or you wanted to prototype some particular sort of futuristic technology that you don't have available yet. Anybody remember what the technique was called to do that and how it works? Yeah, Sarah.
It was the Wizard of Oz technique, I think.
Yes.
And it's about someone being in another room or something and listening and reacting to whatever the user says. And it looks like it's really happening, right? And the machine is really listening and working properly.
Right, exactly. And so usually the user doesn't see or hear the wizard directly. They may not even know that that person exists, or sometimes they do, but it's quick to fall into sort of this kind of like suspension of disbelief state where you just then interact with the system as if it was really working as a user. So that's the Wizard of Oz. Last thing, maybe there was a reason why we did paper prototyping early on. There was also, this was connected to a danger of software prototypes that kind of look very, very finished, that, for example, you do with a user interface builder that looked like the actual interface of the final system. Do you guys recall why we start with paper? Because that's something I keep getting this question, and when I do workshops with industry, they're like, why do you make us draw stuff on paper? Right? We could do this in our computer, and we could whip up Visual Basic, we could whip up that prototype directly, and it would look so much better than our bad drawing skills. Why are we doing this? Yeah, Victor.
Yeah, if I'm not mistaken, we do it for not to go into details, but keep clear with our ideas. So we would like to present the main goal of our sketch. And basically only a pencil-based sketch won't be such detailed as we could provide with a computer. Yeah,
exactly. So you want to get the rough feedback first, the high-level coarse feedback on your general interaction plans before you get into details about, this button should be a different color. All right. Okay. So today, evaluation. We're going to talk about three things. We're briefly going to touch, when you evaluate, why we're doing that, and where and we do this, and what we evaluate. Then we're going to see concrete methods, and that's going to be the biggest chunk of the class today. A bunch of methods to actually evaluate interface designs and prototype implementations, or even finished systems. Sometimes you start out and you're like, I'm going to start by maybe taking the closest competitors of what that are existing on the market today and run them through a user study of myself to figure out how people get along with those and see what these people have, these systems maybe are missing right now before I jump into my own designs. And then we're also gonna have a big, or not so big, but a section on how you work with users, how you deal with users in all these kinds of studies. So first of all, when you evaluate, I already said, it's obviously that third step of the DIA cycle, right? You do this in the analysis phase when you get into, when you've got your prototype finished and you want to figure out whether it's the right way to go. Remember, these prototypes are questions, right? A prototype is a question. I like this metaphor. It's there to ask a question that you need answered, right? You don't build it for its own good. You build it to answer a question. That's true for product prototypes that you need in an industrial product project, but also for research prototypes that you build. You never build these just because, you just always build them because you're asking a question that you want answered. So a prototype is a question, and in the analysis phase, you ask that question and you hopefully get an answer. In a typical interactive system design project, we evaluate for a bunch of different reasons, right? We do this because we just want to understand whether what we design actually fits the needs that the user has. And this is actually necessary even if you already did, for example, interviews with users and your design step was user-centered, right? You could do a user-centered design step and collect all this information. But if you then don't go back to these users and say, did I get you right with this prototype? Is that what you're envisioning, or does that make sense to you? Then you're missing the boat, right? You need to stay in that loop with user interaction so that you actually develop something that makes sense to people. And just to emphasize is we're surrounding ourselves in society so much with digital technology, left and right, everywhere. Everything is being permeated with digital technologies. That is super critical that we get this right. If we keep bringing out stuff that doesn't really work for people, that makes them feel uncomfortable, insecure, or maybe at risk about their personal data, or just incompetent because the technology isn't geared to their needs and their skills, then we're really messing things up big time for people. It's like if we were architects, 500 years ago or so, and we were only building, houses without windows, right? That's a really bad idea. So today we are kind of like the architects of a lot of the environments that people need to live in, and that they need to live and breathe every day when they sit in front of their laptops, when they use their tablets, their smartphones, when they go online. All of this is surrounding people with technology that has to be designed in a way that it works well for them. So this is a big responsibility that I think we have as IT experts, because we're shaping that environment that people live in these days, maybe even more so than architects do these days. So just saying that, I think this is important to get this right, and that's why it needs to happen throughout the entire process, right? So very early on, in the first couple DIA cycles that you do, you're going to do paper prototypes. Maybe you're going to throw these into maybe a design session with your design team. Maybe get a couple users in to get this feedback. And then as you go through more and more of these cycles, you're going to move to software prototypes that get more and more advanced. And there tends to be a slight shift. So whereas in the early stages, you certainly need to involve users as well, but oftentimes you can resolve a couple major issues that you just overlooked also in your design team. Just having somebody else look at it from your team and say like, oh, look, you ignored the law of closure in your design here. It's breaking some fundamental UI rule that you should be following. So then you can find these things within your design team, not involving users. A lot of the early tests are often analytical, informal, and then the more you move down the path here, the more you're going to involve larger and larger groups of users. Why? Because a big design mess up you can find when you throw your prototype at 5, maybe even just 3 users. They're probably all going to stumble over that issue that you have, if it's a big major issue. So you don't need that many people to discover these big major things, because they're very likely to be discovered even with just a few users. But once you get into the finer questions of your design, then you need more people, because you may actually have to get a broader coverage of individual user needs. There may be details that work well for one person, don't work so well for the other person. So the further you move in your DIA cycle iterations, the more you do these, and the later you are basically in your overall project, the more you will start looking at larger user populations to evaluate things, more formal evaluations with interview templates and questions you ask, and that you evaluate, then maybe even statistically, experiments that you record and evaluate carefully. Okay, so this will become very realistic for you guys also in your own projects, because when you think you've made up, you've come up with some smart decisions for your design after talking to some users, if you then don't go back to your users and you just use what you think are good ideas from your team, then you're going to be set up for trouble, right? It's possible, but unlikely that you actually hit the actual user's needs. And so we want to evaluate also to to judge whether the system that we are developing or the design that we are currently creating is actually facilitating the user's tasks. A great way, if you just wanted to have one thing, I think I mentioned this before, but if you wanted to, one thing that people are striving for when they interact with technology, then it's usually they want to feel competent. Users want to feel competent when they interact with technology. You want to feel competent when you interact with technology, right? The last thing you want is you're pulling out your smartphone in front of your friends because you want to show them a photo or you want to share a photo with them that you've got on there. And then you struggle with the interface and it doesn't work. And you're like clicking and tapping and you're not getting it solved. And everybody's like, snickering because you don't know how to use your smartphone. That's like the worst thing, right? And nobody wants that, whether it's in the business or in a private setting. They always want to feel competent when they use technology. So you need to figure out whether the system can do that, whether your system design that you currently have in your prototype actually does that. Does it facilitate the tasks that the user wants to do with them, like sharing that photo, for example? Does it offer the right features in the right place, easy to reach, and are they presented in a way that as expected? Got a wonderful example on iOS when you are like on a website on your iPhone or your iPad, and you want to look for something on that site. You often need to search for a word on a large page, right? On a long page, you want to look for the word, I don't know, student, right? The way you do that is by hitting the share button, which makes no sense, right? I'm not sharing anything. I want to look for something. That's clearly a case where the designers were like, oh crap, we need to place an icon somewhere for searching on this page, but we're on a tablet or even on a smartphone. We don't have a lot of space. We want to keep the interface uncluttered. And so they just jammed it into the share menu, which doesn't make any sense. And even though I knew this, it took me a couple of times to remember this. As more than once I had been struggling with like, oh, how do I search on that page again? Oh, right, I need to hit that the share button. So that's something that, where it wouldn't be presented as expected. So those kinds of things you want to discover, right? You also want to judge something a little more subtle, which is what effect does the system have on your users? How easy do they find it to learn the system and use it? And note that these are two quite separate things. You can have a system that is really efficient to use and very fast to use, but it takes a lot of time to learn. Usually you have that in expert environments. For example, if you ever get a chance to watch a graphic designer, a professional graphic designer, use Photoshop, look over their shoulder. It's amazing. They are like magicians, right? They do stuff, they use keyboard shortcuts and weird tool combinations that it's just a joy to watch, right? And they are highly competent in this, but I can assure you it wasn't easy to learn that. It took them years of practice. So sometimes learning and using the system are things that, where it can be easy to learn, but then maybe the usage of it is not hard, but maybe cumbersome and slow, right? That would be a system that you only want to use occasionally. Whereas an expert system, you want to make very efficient, and it's okay if it takes a little longer to master, to learn. You want to figure out how people feel about the system. So I know this is a computer science class, and now we're talking about users' feelings. Woo. But you need to capture whether people are getting frustrated by trying things out in a way that they think they should be working. Because that's exactly the kind of thing I talked about before. People want to feel competent, and you need to match the user's tasks and their expectations, how things should be working. And are there particular areas that overload them, where they're like, I don't understand this. I'm not sure where I need to go now, or what I need to click, those kinds of things. And then finally, you evaluate to discover specific problems. Do any unexpected or confusing situations come up? And I can guarantee you that they will. It's amazing to see what people discover as designers when they let actual users try out their prototype or their system, and you will be surprised too. People will do everything imaginable with your interface, and then they will do some things that you did not imagine at all. So that's something that you should keep in mind. You will always be getting some surprises out of your user evaluations. Keep your eyes open and stay unbiased, and to be open for these kinds of things. I just remember the help call to a helpline where somebody said, oh, I don't know, I'm trying to install the software from the DVDs, and it's working fine with the DIS1, but DIS2 it just won't work. I can't put it into the drive. And then after a while, the support team found out that the user didn't remove the first disk from the tray before trying to insert the second one. And so it's a simple thing, and you would never come up with that if if you were the developer of that system or the person who wrote the installation instructions, but it happens. So where do we evaluate? There's two fundamental classes of locations, if you want, where you can do your user study. One place is in the lab, and the other one is out in the field. The lab has a couple of advantages. You take people to your usability lab. Like, for example, we have a room at our lab where we have a sort of a see-through mirror/glass wall. So we could, in theory, observe people on the other side while we're being, shielded from them. We could talk among ourselves and do our own audio commentary on what we're seeing. And you can have, AV recording equipment set up there really easy, and you've got your special computers that are equipped to record keystrokes and capture what users are doing, all those kinds of things. You don't get any disruptions because people don't have their desk phone from their workplace on there because they're in your lab. It's quiet. So this is all great, but you're also, and this is a problem with lab studies, or a challenge that you need to keep in mind, you're not in the natural environment, right? The user doesn't have their normal shelves and wall calendar and whatnot around them. And for example, if you are writing an email, if you're designing a new email client, and you may not notice, or you may not get a chance to notice that people are often just, peeking up at their wall calendar to figure out what date will work for a particular appointment for them before they send an email about that. You can only capture that if you are in the user's actual workplace. Also, the situation will be kind of unnatural for the user. Let me explain the picture here on the right. So in the back, we see a person sitting in front of a computer, and they are the user, right? They're in this experimental room. And then there is a wall here that has like a semi, transparent mirror. And the person in the front of the picture here is actually typing on a laptop. You can see this is like probably from the 90s. And she's taking notes on what the user is doing. She also has multiple video feeds of seeing the user from in a profile to see their facial reaction to things. And then she gets a recording of the user's screen here live on a second monitor, and something else on the third one. And also has ways to take notes on her laptop here, right? So that's a typical usability lab with all this special equipment in place. Why is this unnatural? Well, because this in the back is not the user's normal workplace, right? This is a lab that is made to look like an office workplace, maybe. So the relevance of what you are observing may be limited to what people will be experiencing in their real actual environment, right? You may observe behavior that will not actually occur, would not have occurred if people were in their normal work setting. But in some cases, you just need to do it that way. For example, if the real location that you wanted to do this at was like dangerous or remote, like the International Space Station, right? If that's where you're developing for, you probably won't be able to do lots of field studies, right? You need to simulate in the lab. And sometimes it's also good to have a controlled situation. For example, if you wanted to test something like, when I arrange my menu circular versus linear, what works better? Which way is faster to select from? That's a very defined, very focused cognitive task. You don't want any disruptions for that, right? You want just to figure that out in isolation. And then a lab study makes sense. But we have sort of the other situation, which is being in the field, where you study the user in their natural environment. This is definitely more realistic, in part because of the disruptions that are happening, right? The situations and the behavior that you observe, how people actually act in these natural environments in their normal workplace, or at home if you're developing something for use at home, or in the gym if if you're developing a fitness tracker people are supposed to use in the gym. This will all be more natural for them, and they will behave more like they do in normal life. It's also better suited to long-term studies, because you can let people go about their normal lives and then use your prototype as part of that. One example of that that I recall is a student that I met in the US went out and observed dental assistants and dentist assistants for several months, and how they get trained. And she did that at the clinic and at the school where they were being trained. And that would have not been possible to do in the lab, right? You can't expect people to keep coming to your lab for something. And in fact, this wasn't what she was looking for. She wanted to understand the real work practice to capture. Of course, all the task interruptions, we see here, we see poor Milton Bottoms from the movie Office Space sitting here and being overloaded by paper and probably getting phone calls all the time. So the whole interruptions that are happening can also be a problem, right? If people keep getting distracted from your task, you may not be measuring what your system does, but you may actually be measuring more like what the environment as a whole is creating, and that's not just your system. And it would be naive to assume that just because people are in at their normal office desk, that they no longer feel being evaluated, right? It still will feel a bit like a test situation for the user who is part of that study. We'll talk about that later, how to address it and how to fix that in certain ways. Yeah, by the way, yeah, thanks, Victor, for the question of prototyping part of the design or implementation in the DIA cycle. It's a good question. And Ali is right, you prototype in the implementation phase. So implementation, when I say implementation in the DIA cycle, it sounds like coding, but it's not, right? Building a paper prototype, for example, is absolutely implementing your prototype, building it. Design is really where you are, where you're thinking, discussing what you're going to be changing, and once you have a plan for how you want to change things, then you put that into an actual physical form with your prototype in the implementation phase. All right, participatory design is something I want to mention here because it is it's a variant of user-centered design that is kind of extreme, if you want. It originated in Scandinavia, where actually it's required for certain products legally. And what it does is it doesn't just involve the user in the evaluation phase when you test things or analyze things with them, but it involves the user through all the three phases of the DIA cycle all the time, through the entire design and development process of your product. So you have user representatives being part of your design team. They are there when you build your prototypes. And so you constantly have somebody to talk to and to ask, what do you think about this? Or they can pitch their own ideas into the design as well, right? It's not just they're not just being asked certain questions that they answer or observed using certain prototypes, but they are actually an active member of the design team. This requires a lot of advanced techniques for team communication, because you now have somebody in there who is maybe an excellent chef, like an excellent cook, right? Because you're developing an application for restaurant kitchens, but he's not a programmer and he's not an interface designer. So you need to use all these techniques of brainstorming, storyboarding, workshops, interviews, role plays, paper prototypes. All these become very important to get to a common language that you can both speak. And this is challenging. First of all, you are actually requiring somebody to kind of leave their day job for weeks or months at a time, and to come to regular design meetings in your team. And that is expensive, of course, right? Because that person isn't doing their normal job during that time. That's the first challenge. The second challenge can be, maybe you've got that chef on your team, that cook on your team, but the software you're developing on the end is going to be purchased by the restaurant manager. And then maybe now the chef is going to put his own interests into the design. Obviously, he's going to be doing that. And those may be conflicting with what the manager wants to see, right? The cook wants to create the best food possible. The manager has, budget constraints and economic reasoning behind his thinking. And so you may get influence into your design that matches what the user representative is about, but may not match what other user representatives that you don't have on your team are about. And that's particularly dicey if that manager is the boss of the cook, of course. And then we also sometimes speak of user conversion. After a while, somebody who's been part of the design team will start to think more like the design team, and will kind of move away from this sort of untainted original user perspective. And you often need that untainted user perspective to be able to evaluate your system realistically, as if it was being used by somebody who's never seen the system before. Right? After a while, this user representative who's part of your design team has seen so many ideas go by and knows so much about the hard thinking and the reasoning about certain decisions, that he will no longer be ready to just wipe them off the table because they don't make sense for him as a user. So that user conversion is a bit of a challenge there. It's kind of a bit like the Stockholm syndrome, where hostages start expressing empathy towards their captors. All right, so with that in place, we're now going to look at evaluation techniques. This is the big overview slide that you're going to see a few times today, that shows you what we're going to be going through as techniques. First of all, we're going to talk about a few techniques that don't require users. And you're going to say, wait, evaluation without users? I thought it's all user-centered and we always need users. Well, we don't always need users. There are certain things that you can discover without users, which is good because that's faster, cheaper for you to do. And you can do more of those quickly inside your design team without having to recruit users to come to your lab or visit them in their workplace. So those techniques we're going to look at: literature review, cognitive walkthrough, heuristic evaluation, and model-based evaluation, which is a whole section in itself. And we're going to take a look at GOMS as an example of that. Evaluation with users is the second branch, of course, where you do involve users in your testing. So now we have users being present in the evaluation step. And for that, we have qualitative methods, and those are the ones that we're mostly going to be covering here: model extraction, silent observation, think aloud, which is probably the one that you're going to hear, you may have heard about already, because it's very popular in the industry, constructive interaction, and retrospective testing. And then we have got quantitative methods, which are essentially controlled experiments, which we often do in research, not quite so often in industry projects, although they also happen there sometimes. So the whole evaluation without users, we talk about that first, also because it tends to be something that you do earlier in your process, right, during the earlier cycles. You don't do an extensive test with thousands of users if all you have is a paper prototype, right? That's not typically how it goes. Maybe just a few words here on qualitative versus quantitative. That often gets confused. Qualitative means that the kind of data that I'm collecting is not statistical or numerically expressed, right? I'm not measuring things. And the quantitative one means that I am collecting, measurements, statistics, etc. So in qualitative, you're often asking things like, did something weird happen in the interaction, or did it work at all, right? Not so much, is my interface 20% faster than the previous design, right? The qualitative studies are often trickier to process statistically, but they often give you insights that lead you to new ideas, rather than the quantitative ones are more about evaluating an idea or a hypothesis that you already had in your head. Okay. And then, of course, there are things like interviews that you can do even without having any prototype, or questionnaires that you can pass out, that you can do certainly as part of your DIA cycle with a prototype, but also you can run an interview just figure out something about your user base, or about how they use an existing system that you are starting from to improve from, run questionnaires and so on. So the first ones are fairly simple. Literature review, that's just basically, this is not a study, right? A lot of the research results about user interfaces and have already been published, right? So the idea here is, if you are designing a new system, and maybe you're designing a new interactive whiteboard application or something, and at some point you're wondering, should we use linear menus or pie menus, right? Circular ones, right? Go into the literature, check out the ACM digital library, look for linear versus pie menus, and you'll find at least a dozen papers that talk about this topic and that have analyzed it to death. So you can learn a lot about reading the literature. That saves you running a study, right? You're running your own study. As some people say, ironically, a lot of people, a lot of students, or a lot of practitioners seem to work in a way that they say, oh, following the mantra, spending a few weeks in the lab can save you a whole afternoon in the library, right? That's kind of the twist on things. You often find people really struggling, and then they basically discover something that they could have just read up because other people have discovered that before them already. So read the literature, it's really worth it. And one thing that you need to be, of course, aware of is you need to check carefully whether the setting in which the other paper describes its experiment, or the results that they found, is matching what you have. So for example, back to the idea of linear versus pie menus for a walls, or an interactive whiteboard application that runs in a classroom. If people did that study, but they did it with people interacting on their smartphones, that's a very different setting, right? It may not apply to your environment, because now you're talking about a big, whiteboard where the physical movements are completely different, whole arm movements, versus just your fingertip tapping or selecting things on a smartphone. So your user base has to be similar, your tasks have to be similar, your contexts have to be similar. But if you do this, you save a lot of time, effort, and people involved in it. So that's the literature review. The second one is cognitive walkthrough. And this is a very interesting technique, because you don't actually need users for this, and you don't even need a complete prototype. You're going to be like, well, how can I evaluate something if I have neither of those? Well, all you need for this is a description of the UI, which can even be a textual description, so that you know how the UI will be working, right? You also need a description of the task that is to be executed, and and you need an expert that knows how to run this thing. And finally, you need to understand who the user is. So the user profile is also important. So this lets you evaluate the ease of use and the learnability of a system without involving users. You do this when you are in an early design phase, where you don't have a system available, or when you are looking at an existing system. You can also do a cognitive walkthrough, because of course, having a working system available doesn't hurt. No, it's helpful. It's just that you don't absolutely need it, like with pretty much all the other techniques that we're going to be talking about. So you need the expert, who is like a designer, cognitive psychologist, somebody who took this class here. You need a description of the UI. You need a description of the task. You need a description of who the user is, and you need a description of the context. Description of the user means like, what is the user likely to know or not know? How are they likely to, what kind of background knowledge are they going to be able to bring to this? What kind of experience do they have with systems like the one you are about to test? Task descriptions means things like, for example, if I'm designing a new, emergency cell phone, then placing calls or receiving calls would be typical tasks, or storing numbers or something like this. For each of these tasks, you then kind of go through that Norman model of goal, interaction, intention, action sequence that we learned earlier. And it's called cognitive walkthrough because you're walking through the interaction of the non-existing interface, possibly non-existing interface, in your head, right? You're imagining the user interacting with the system. So you don't have a user around, you have or have not an actual prototype, but you're trying to imagine what it's like. You put yourself into the shoes of the user and try to imagine, okay, does the system help the user to get from the goals to intentions and actions? What kind of knowledge and cognitive processes will the user need for this process? What are we expecting from the user? For example, if the system uses very technical language in the interface, calls things by technical names, then we have to make sure that we check this with our user profile, whether that assumption is realistic, right? Is it actually likely that the user will know these kinds of terms? And then finally, what problems could doing this step have, or what problems could learning how to do this step bring with them? Will the user be able basically to perform these stages of the 7 stages of action without any gulfs, right? That's kind of what you could ask yourself. Can the user predict the UI and its behavior appropriately, or is it doing things that they wouldn't ever have expected? So we're kind of going through the left side of the 7 stages, if you want to be, right? You're like, you're playing to be the user, you could imagine. This is difficult to do because your prototype inside out, right? You know what you've been building. So it's hard to play somebody who is completely unfamiliar with that system. So you've got to be careful that when you do this, that whoever is running the cognitive walkthrough is careful about their own assumptions, right? You kind of have to unlearn the interface if you know it already in order to be able to do this properly. Sometimes people do a cognitive walkthrough along question forms. The question forms are basically pieces of paper that list questions that you ask yourself, and that helps you to be reminded of potential psychological limitations or knowledge limitations that the user may have. So in a way, the questions are like the HCI expert, the psychological expert who puts his thought process into questions to guide you through this kind of evaluation. And that actually leads to evaluation technique number 3, which is very much based on existing question catalogs and checklists, if you want. And that technique is called heuristic evaluation. Heuristic evaluation is a variant of cognitive walkthrough where you use existing usability heuristics. So you basically have a checklist of things that you're going to go through at each screen of your interface. And you're going to go along and see if these have been fulfilled. We're going to see such a list later on ourselves, which we call the 10 golden rules. In this, you step through the task then that you also have broken down, like in the cognitive walkthrough, you need to know what the task is. And for each step in the task, you check whether all the guidelines are being followed. For example, is the system, does it speak the user's language? Does it use words from the user's own natural vocabulary that they would know from their domain vocabulary? Or does it offer a clear way to undo the last step of the action that we just did? Those kinds of things you can ask yourself. It's a quick technique, it's cheap, but it's pretty subjective because the questions in these guidelines and heuristics are fairly loose, right? There are guidelines like keep the interface simple, but what you consider simple, I may not consider simple at all. So you often have to do this with several designers independently of each other in order to get to a reliable and trustable result. For example, you might have two users with the same rules of, does this user interface, is this a simple user interface? And then the Linux geek says, oh, great, yeah, the interface uses a console interface. I know that from my, command line. I'm happy, this is super easy. And a different user without much Linux knowledge is like, no, that breaks the rule of simplicity. This is totally not easy to use. So you need to ask multiple people and find a balanced result there. This variant of heuristic evaluation is still something that people do a lot because it is such a quick thing to go through. And you kind of find issues there that are fundamental problems of usability that always, where the rules always apply. We will actually have a separate lecture later in this class that gives you an example of these, 9 or 10 golden rules that you can, go through and check. They always apply, which is both a strength and the weakness, right? They're always true whether you're developing a system for the box office of a movie theater, or whether you are developing a command module for the International Space Station. These rules always apply. It doesn't matter who the user, context, or task are. But of course, that means you only capture a small amount of issues, right? The larger part of doing good user interface design means you really need to understand and empathize with your users. Just to clear this up, heuristics means, in general, a heuristic is kind of like a rule of thumb, right? It's a guideline. That's what the word is being used for in this context. So moving to E4, model-based evaluation. There are some models out there, and with models, I mean things that are more theoretical and more mathematical in nature that actually give you a framework to design and evaluate interfaces. We've already met one of these models. If you think about Fitts' law, for example, that's a mathematical model of how users move, their finger or a user input or an input device from a starting point onto a particular target location based on the distance. And there are some more involved models that let you actually think about complete interfaces. And the beauty of this is, remember, we're still in this section of testing and evaluating without users. The beauty of these models is that they predict human behavior and performance without you actually having to run tests, because in certain levels of interaction, people are actually quite predictable. Not in the higher cognitive levels, because people differ hugely in that. Everybody's got a different background and different education and different assumptions. But when I'm just asking you to move your finger from A to B as fast as possible, as you saw in our experiments in class, we're kind of predictable that way, right? There's a certain way that we do this, and we have certain performance parameters that you can measure. And once I've measured these and created a model out of these, I can predict performance in another interface without having to run the experiment again, right? The model captures the user's abilities in this particular domain, in this particular task. So that's what these models are about. They capture this kind of behavior and user behavior, sorry, as examples of sort of giving you a way to predict things before they, without actually having to run through a complete technique there. I want to mention 4 examples here. The first one is probably the most involved and maybe mathematically, well, I don't want to say complex one, but the most structured one, which is called GOMS. We're going to talk about that afterwards because it's a whole section in itself. And I'm not going to do that here now so that we can get through our 10 different design techniques first. And then we're going to take a deep dive on GOMS later. GOMS and the KLM, the keystroke level model, are models that let you evaluate a design and that basically predict how long it takes a person to operate an interface. You know, how long does it take a person to do a particular thing in a user interface? Mostly based on clicking and typing and those kinds of things. The second one that we're going to talk about is information efficiency, how you can measure the efficiency of a user interface mathematically. This is also based on channel information channel theory, and predicts how much information is coming across in interaction between user and system. The third one, design rationale. We're also going to talk about information efficiency in a bit more detail later on. Design rationale, I just want to touch on here very quickly, is a concept in which I basically, let's say you did a user interface design project, right? And every time you made a decision, you capture the design decision and you write it down. You keep a log, so to say, of all your decisions and the reasoning behind your decision and the alternatives you looked at. When you do that, then you can actually use your design rationale the next time as sort of a repository of knowledge and of decisions. And you can go back and say, well, we don't need to decide again or to reason again whether we want to use pi menus or linear menus, because we've gone through that in the last project. We did a study. In the end, we decided with our study with this user base that pi menus were the way to go. So we can just use pi menus because we know this. So design rationale really builds up a knowledge base, if you want, of design decisions that is very much often geared towards your user base and your particular interface challenges and your technologies that you're using. And finally, there's Hci Design Patterns. Patterns are kind of design recipes, and they are answers to recurring questions in user interface design. They are a bit like a collection of design guidelines or rules, but they're a bit more structured like that. I wrote my PhD thesis on that. In fact, the thesis I wrote ended up being the first book on Hci Design Patterns many years ago. Nowadays, it's become a commonly accepted format of capturing knowledge about user interface design. We talk about this in more detail in the current topics in HCI lecture, but I want to give you a big glimpse of how design patterns work because they're actually a very useful format to capture design expertise. So imagine yourself being an interface designer who, you've taken DIS1, you've done a few projects, you know your way around interface design, but you've never designed software for meeting rooms, right? Or an interface or a system for meeting rooms. So you're like, okay, I don't know how these kinds of systems work. Who can tell me? Now you could just look at a lot of existing meeting room software and evaluate it and try to look for common solutions that people use that solve problems that the users keep having. But wouldn't it be nice if you had this knowledge sort of distilled for you in a collection of rules, of patterns that explain to you what the particular challenges in meeting room interface design are, and how you solve these, and what the pros and cons of these solutions are. Well, that's exactly what a collection of design patterns is. I'll show you an example of one of these design patterns that I wrote this myself, was published more than 10 years ago. And it's part of a pattern collection, or we call these pattern languages, that is for meeting rooms. And this pattern is called social protocol. I consider it a very essential pattern for meeting rooms. That's why it has 3 stars behind the name. It's like a 3-star ranking if you want, 0 to 3. Here's a picture showing you what it is about. Here's a person, 2 people working with a bunch of wall screens here, and they each have their laptops here. And it looks like this person on the left is just handing over this mouse, this wireless mouse, to the person on the right. So they are trying to pass the pointer, who can control the wall display up there, from one person to the next. Next in this pattern, we have an explanation of when this pattern becomes relevant in designing an interactive room software. Once you've picked sort of your hardware to control the room and its services, and it looks like this is actually pointing to another pattern called room controller here, that we don't know anything about, but we could look it up in the pattern language. And the current point in design where we should be, if we look at this pattern, is, you now need to decide how the technologies operate by the users. And then comes a little problem statement that describes what the issue is that we're facing, which is often that, if you have meeting software in there or an interactive room technology, it often needs to be told that something happened in the room. Like one person wants to pass control over a shared display to another one. We have this here in our Zoom sessions, right? When I want Oliver to share his screen, we kind of have a little dialogue, and I say, like, okay, Ollie, can you take over screen sharing now, right? So we often have this social interaction, a social protocol of dealing with this. But sometimes the software then still requires me to do something in addition to our social negotiation that has just taken place. And that's really bad, because we always forget about that part, right? So as an example, I might say to Ollie, okay, Ollie, could you please take over screen sharing now? And he's like, sure, I will do that. And then he says, oh, wait, Jan, I can't take over screen sharing. You still need to hit that particular button in your interface before I can do that. That's a bad design, right? So there's then a couple of examples in this pattern here of giving you good solutions to this problem. We don't need to go into detail of how this works. There's also some bad examples here of meeting software that, that is being controlled by voice control, and then everybody has to like shut up in the meeting, and then one person needs to talk to the computer in very clear terms, and then everybody waits for the computer to respond, and everybody's like frozen in place. Terrible. Early MIT research video that is like a completely dystopian vision of the future of meetings. Anyway, after you've gone through these examples, then we have a solution there which says try to not place any unnecessary protocols into place that are aimed at avoiding overlapping access to technology. In the example of screen sharing, for example, if you enable it right, then Zoom just lets everybody share their screen at any time. And you, at least in a meeting with a controlled number of participants, you can be sure that they will negotiate any conflicts in access via the voice channel. They'll just say, oh, wait, could you stop sharing? I need to show something, right? We don't need a particular token passing from one person to the next for this. So that's the solution, saying, support social protocols and don't put any extra effort into place. And then there's a little sketch that shows there's an interaction between 2 people. You can see this was an early version of, me trying to get away from stickman drawings. And this interaction between people, the computer should kind of be listening in there on the side, understanding what's going on between these folks. Okay, now I've talked you through this pattern, and it's not so important to understand this particular pattern social protocol. That's not my point. I just wanted to show you how a design pattern works. It's a communication device. If you guys are TK students, you know what I'm talking about. It's a document form. It's a format like a novel or a newspaper article or a letter where you know where to expect certain things. So we have a name of the pattern called social protocol, and the name is super useful because once you've read this pattern, you can use the word social protocol in your design meetings as a concept, right? It becomes design material for you. You can use this concept to negotiate the design in your design team. It has a sensitizing image that shows an example of the system in use. It gives you context when this pattern should be applicable. Like what things should you have thought about before you get to this question? Then it gives you a problem statement. It gives you examples of how this problem can be solved. And then there's a solution, which basically is sort of distilling the examples into a general recommendation, which is kind of like a guideline, a design guideline, or like a golden rule or something like this. But it's pretty concrete because it actually tells you how to solve the problem, and it gives you some examples of how to do that. There's a picture that breaks it down into a little diagram, and then it may reference other patterns in the language that you need to look at next to further implement this particular solution. So that's a design pattern in HCI. And as you can see already, if you were now to go into a meeting with your design team to design some interactive room software, and you all had looked at this pattern language, then social protocol, the term social protocol would become for you a part of your vocabulary that you use in your design discussions, right? Even with your users, you can even share this with your client or your users, and this is easy enough for them to read, and so then everybody has this vocabulary. That's actually what I did. I wrote a design pattern language as part of my PhD thesis on interactive exhibits, interactive multimedia and music exhibits, because I built a couple of these as part of my research. And when we were going to a new client to design an exhibit for them, I would give this pattern language to them and say, this is the kind of principles that we follow in our designs. And once they knew these, this became sort of common ground between us and the client. And it was much easier to discuss later decisions. I could easily explain why I need a big screen for an exhibit rather than a small one, because pattern so-and-so explained why that was important. Patterns actually appear in HCI quite early. If you look at Norman's book, The Psychology of Everyday Things, that you've all read, you will actually find a reference to patterns in there. He references the design patterns from Christopher Alexander. Christopher Alexander was an architect, is an architect, and he came up with the idea of design patterns for architecture in urban settings. He wrote a book on how to create design patterns, and he created a pattern language of like 200 or 300 patterns that all describe how to design good neighborhoods, cities, houses, rooms in an urban setting. So it captured his design values about good urban design. And Norman references this and says, this could be interesting for HCI. I'm not sure. It's fascinating to skim through these these things. If you read them in length, they're kind of like, quite demanding and frustrating to read. That was his take on it. And I spoke to Don Norman a few years ago about this, and he reiterated his assumptions there. And then it actually appeared even in an earlier book by Don Norman in User-Centered System Design. He referenced it. And that was so early, that was earlier than where you have probably heard about design patterns, which is in software engineering, right? Quick show of hands, who of you guys has heard about design patterns from a software engineering standpoint? Can you just raise your hand if you did? Yeah, a lot of people. That's what I would expect. It's a fairly common technique in software engineering, right? And software engineers use design patterns all the time these days to capture how to design software internally, right? But the way that we use design patterns here in HCI that I was suggesting in there, and that has become sort of quite commonly used now, is to use them to capture interaction design, not software design internally, how you structure your classes and so on, and your modules, but rather how you structure the interface. You can also find a reference to pattern languages in the Apple and Macintosh Human Interface Guidelines as early as 1992. So a lot of people had noticed them in HCI, but nobody had really taken the effort to bring them to HCI, and that's kind of what my PhD thesis was about. here's this example of the language I was talking about that I designed as part of my thesis back then. It's a small language that gives you a couple of patterns about how to design interactive exhibits. And they capture things like attract, engage, deliver. At the very top is a pattern that says you need to pull people. If you're designing an interactive exhibit for a museum, you need to make sure that users get sucked into the exhibit so it's attractive to start to play with it. Then you need to engage them for a while. And then you also, and that's something people often forget, you need to let them go, right? You need to finish the experience so they don't play with it for like, an hour and keep the visitor flow from happening. So that they leave with a clear message what they learned about in this exhibit, especially in the Science Museum, for example. And that's one of the patterns. And there's lots of others in there that we could talk about for a long time. Basically, if you read all these patterns, and each of these is a couple of pages of text in the exact same format that you just saw, then you have a pretty good handle on how you can design successful interactive exhibits for like science museums, tech museums, and the likes. All right, so that's pattern languages, Hci Design Patterns. Nowadays, you can find lots of books that use the design pattern format for mobile design, for website design, for voice interface design. A lot of people have taken particular domains and cast their expertise and knowledge and their design school of thinking into a pattern language for this domain. It's a really fast way for you to get up to speed in a new area. Okay, so that's design patterns. Now, this concludes the discussion of evaluating without users, right? This is all not necessarily involving users. But of course, oftentimes you want to involve users, or you have to involve users, and you should be involving users. And so we're going to now look at these areas here on the right-hand side of our tree. That is a collection of techniques that all involve the user as part of your evaluation. As soon as you have these prototypes, these implementations, it really makes sense to also try to go for testing with users. And that's what these methods are for. So let's go through them. And you will find that actually E5, E6, E7, and E8 are actually kind of improvements or building on top of each other. But that doesn't mean that you always should only do the last one, E8. Sometimes you don't have the time or resources to do it, and then the other ones will be fine too. But let's start with the simplest one, model extraction. You're the designer, you have your prototype, which is just a paper prototype, for example, like screenshots, for example. You show them to your user, to a typical user representative, and you just ask them, what do you think this is? And you have the user explain to you what they think this interface does, right? How does it work? How would they use it? What do they think it can achieve? By having the user explain your interface back to you without them having learned it before, really just seeing it at first sight, you get a real good sense of what the naive sort of first impression conceptual model of the interface is. I bet you if somebody had taken the Swedish hairdryer and had given it to a user and said, explain that hairdryer to me, they would have quickly noticed that they messed something up, right? So the idea is that this really lets you get the first sort of naive user's conceptual model of the system at first glance. Right? What's the at sight reaction? Do you get the interface? Do you get it? And what do you get from it? So this is useful. It's quick. It's easy. And it can tell you things a lot of things already, but it's missing a few things. First of all, we don't learn anything about how the system is being learned over time, right? It's just this first encounter kind of reaction. And more crucially, we're missing the task and context here. We don't give the user anything that they should be doing with this interface. We're just showing them an interface. So let's add a task, and that is then technique number E6, silent observation. Here you can see a little bit of an icon for a setting here, and these pictures are all from esteemed HCI researcher Saul Greenberg, who created these many, many years ago, which you can tell by the fact that this is actually kind of like a Mac Plus model from 1984 here on this table. But the technique hasn't changed, right? I promised you early on that this class will be teaching you things that don't become obsolete next year. So this technique hasn't changed, even though the technology that you test has changed. So there's a person sitting here, that would be the user on the right-hand side, operating a system that this person, the evaluator or the designer, let's call them, has maybe created, and at least he's now running the test, right? He's running an evaluation. So the designer is basically just watching the user, right? That's all that's going on here. And the designer watches the user working on one of the tasks that they explained to them beforehand, either in a lab setting or in their natural environment. It's both are possible options here. There is no communication between designer and user here in this. Like the designer isn't talking, the user isn't talking. She's just using it, and usually when you do this, you don't just like this guy look at the user's face, but you would also have, for example, a screen capture to can see what she's doing on the keyboard and what the actions on the screen are. So this could be a typical setting also in this lab that I showed you earlier, right? In this lab setting where you've got these recording streams going. Now this is useful, silent observation, and it helps you to discover big problems, big usability problems. It also helps you to really get a completely unchanged and uninfluenced, honest view of how the user is using the system. And you can believe me, this is hard for the designer because you're going to sit there and you are watching the user using your system and make mistakes and getting lost in the interface, and you cannot do anything to help them, right? You can't say, no, don't press that button, right? You're just there powerless and you need to watch them struggle. I had a friend that I met years ago. This was when, you know, user-centered design was just becoming fashionable at Microsoft. She worked at Microsoft and she said, this is what she does, right? When she needs to explain to people that they have a usability problem, to the engineers, she takes the engineers, she puts them behind a glass mirror wall in an observation room. She puts users into the lab room in front of that, and she lets those users, like, I don't know, write a letter in Word, right? And then she lets the engineers watch the users slowly fail, right? You know, with the task, because maybe they are asked to create a serial letter to 100 recipients and they don't get it and they don't know how to do it. And the users are sitting there cursing and not getting it. And the engineers can't do anything. And she says, this is so wonderful to watch them helpless and powerless that they can't reach in and just press the right button for the user. After that, the engineers usually get that, yes, there is a usability problem. Yes, we need to do something about that. So it's a very healthy sort of thing to do if you want to get people on the side of usability issues. It's amazing if you watch users unaided, how they struggle with software, if they don't know it, and you'll learn a lot. But while you see the user struggle, and maybe you get the occasional, oh, this sucks from them, you don't really learn about the mental model that the user has because they're not speaking about it. They're not talking about it, right? You see the user keeps pressing a particular button, but you don't know why, right? They're not telling you why because it's a silent observation. The user is not supposed to speak about what they're doing. They're just supposed to do it. So you don't get the user's mental model. You don't get their opinion on things. And you don't get their feelings, except when they get really frustrated, you can probably tell. So again, how can we improve that? Because this observation means we can just observe what the user does. We can't look inside their brain. So in order to improve on that, we've got the next technique, which is called think aloud. And here we've got the user sitting there, again, doing the same task with the designer watching. Again, the designer is still not saying anything. This is important, right? Designer, no speaking. But the user is now saying like, what does this do? I'll try it. Oops, now what happened, right? So the user is kind of giving the designer a running commentary of her own actions, if you want, right? it's like the silent observation, but the user talks aloud about what she thinks is happening, what she's trying to achieve, and why she's doing something specific. And that's actually nicely capturing these things. It's capturing the state of the interface, telling her, you know, what she thinks is happening is the state of the UI, what she's trying to do, her own goals that she has set for herself, sub goals of the task that she was given. Because usually you know, as a user, you break the goal down into tasks, right? The task down into goals. Like maybe the designer told her to print out this serial letter with 100 recipients, and she's now trying to set up, you know, this link between the context database and the letter she's got in front of her. And then why she's doing something specific, you know, pressing this button. So this is a nice technique. It's used probably the most common method in industry even today. So it is good because you get to understand, you don't just see what the user is doing, but you get to understand the conceptual model that the user has, right? You get to understand the reasoning behind their actions. But there are a couple issues with it still. First of all, it's actually hard for us to talk about what we do while we focus on a task. We're not really wired to do that naturally. Secondly, it also feels kind of weird, you know, when you talk to yourself, you're like that, you know, strange guy on the bus that is talking and muttering to himself all the time. So talking aloud feels weird for most users because they're not speaking to anybody in particular. They're not supposed to talk to the designer because he's not going to respond. They're just kind of like talking to nobody in particular. And finally, there is something interesting. When you talk consciously about what you do, it actually changes your behavior. This is a phenomenon known as reactivity, because you reflect on your actions more when you vocalize and explain them to, you know, even the thin air around you by talking about them, and that may lead you to handling things differently than you would if you just went ahead and did it silently. So that's where we're not getting all this for free, right? There are some challenges in doing that. Now, it feels weird to talk kind of like to mumble to yourself here. How can we fix that? Well, we add another person. Here, we have what I like to call Neanderthal man sitting next to her. And the assumption in constructive interaction is that you now have two people working on a task together. And you then can have the normal conversation between these people that you observe and that you typically also record. And this is more comfortable than think aloud for people. And for example, here, one user is saying, no, why did it do that? And she's like, oh, I think you clicked on the wrong icon, right? So there's a discussion between the users going on, still not talking to the designer. He's still a fly on the wall, right? Silently listening in, and observing. But you have this discussion going on, and it feels more natural to talk to each other than just to nobody in particular. There's a variant of this where you get, for example, you say like, you know, Neanderthal man could be a beginning user who's never seen the system. And the lady next to him here is somebody who has already seen the system a couple of times and knows it a bit. And that way, then you can observe how she trains him to use the system. And while the student, let's call him, Neanderthal man here, kind of like, you know, uses UI and asks questions, and the trainer answers according to her knowledge and her mental model and understanding of the system. And this is super interesting because you will learn how other people think your software is meant to be explained and meant to be used, which is, if you're really, really lucky, the same mental model that you had in mind, but usually it's not. And so it's very entertaining to see how people explain stuff to them, to others about using your software. And so what that gives you, apart from the entertainment value, is you get an insight into the mental model of a complete beginner. That's, you know, the guy here, and what you could call maybe a more advanced user who's seen the system for a little while, the lady here in this picture, and at the same time, right? So you get both of these, and that's probably the most involved, also of course more expensive technique, because you need two people as users. They need to hire or recruit somehow. And you can see, for example, if the beginner gets something wrong, that's not good, but does that mistake get rectified? Can the intermediate user explain it better? Like, do they know how to solve that issue, or does that issue persist and not go away? Those are kinds of things that you understand with this kind of setup. All right, and then we have at the last technique, something called retrospective testing. Retrospective testing means basically you observed the user in a think aloud session, or maybe even in a silent observation, and then you record that interaction that the user has with the system, and afterwards you both look at video recordings together, and the user then comments his actions retrospectively. So you can even do that with the silent observation, where the user doesn't need to talk about what they're doing, she just does it, and right afterwards, when it's still fresh in her mind, you go over the video of that interaction and you ask her, why did you do this? Why did you do that? That's a great way for starting into an interview afterwards, and it also avoids kind of like distorted or wrong memories about the interaction that would happen if you just ask people from the general recollection. How do you typically use your email client, right? This often results in very concrete suggestions for improvement. Here's an example. The designer saying, like, do you know why you never tried that option? Oh, I didn't see it. Why don't you make it look like a button, right? This is kind of like a sample snippet here from that kind of interaction. So it has the character of sort of a debriefing event after the actual interaction. Okay, so this was E 5 to 9, or 6 to 9. I think 5 to 9. 5 to 9. And so all of these require you, or at least is highly recommended, to record things, right? Recording observations is something that is almost always necessary. You may think before you run a test that you will capture everything that goes on and just make some notes on a piece of paper or on your tablet or on your laptop. You won't. You're never fast enough to capture all the things that you find interesting about the interaction. So if in any way possible, try to make sure that you don't just have paper, but also video recordings. But of course, paper and pencil is great, right? So that's the baseline for observing. While you never observe without something that you can take notes on, right? So you note events happening, like user program crashes, or user opens the wrong file or opens the right file. You interpret what you see in there, and you write down any other observations. User seems stressed, those kinds of things. You make notes of those kinds of things. It's very cheap, of course, but like I said, it's hard with lots of details, right? You don't capture a lot of details that way because writing is just pretty slow. You can have some kinds of forms that let you fill out these things where you save yourself a bit of writing effort, but it's usually a bit too slow for you to keep up. You can type instead of write if you're faster typing than writing by hand. Most people in our domain are, or should be, I should say. So that's another option to do it. But in addition to that, you usually want audio recording, right? Especially on Think Aloud and Constructive Interaction, those kinds of techniques. Of course, you want to capture that commentary that people are having, because oftentimes not the whole design team is in the room when this happens, this evaluation. And you want to bring these things back as, ground truth. This actually happened in the test, to the design team, being able to show them or play back to them a little audio snippet of the interaction, or maybe even a video if you have it. We're going to get to that next, so that they really believe that this is what's going on, and that you can together interpret and judge and act on the things that you've observed. So audio recordings are great, but audio recordings are immensely hard to link back to the interface state later, right? Because you would not have a picture of the screen at this point, right? That kind of sucks. So you want video, right? Ideally, you want the screen recording, and you want the video of the user's face as well. And then maybe even, you know, something that shows their hand on the mouse and keyboard as well. You can also, in addition to the, or alternatively to that, you can use screen recording to capture the screen on the computer. That's what people often do today. And use the camera built into maybe the laptop to capture the user's face. Then you've got these two things in one set, and most, you know, machines these days have that equipment. This is, of course, the best way to capture things, right? Have the video and audio and still your note taking that you do in real time. But it may be a bit intrusive, right? Of course, the more you know, more cameras you point at the user, the more nervous they're going to get about how they act, right? And they're going to feel a little uncomfortable. So that's something to be aware of. What helps immensely is if you can have everything get timestamped, because synchronizing the audio and video streams and your paper notes is really hard later on. So you want to make sure that from the beginning on, you have like a watch running, or you take like your real time on your smartwatch, and you make sure that you, when you write down any notes, that they are always you know, preceded with a timestamp that lets you later link it back to the corresponding point in the video and audio. If you need to synchronize different cameras, there's a good old technique that's been used ever since Hollywood has been around, which is, you know, the famous clap, which means I now have an audio clap on the audio track, and I have a visual frame where the hands get together on the video track, and I can synchronize the two tracks easily after the fact in a video editing software to get that sorted out if I recorded it on different devices. Or if I need to synchronize multiple videos, that's also useful, because even in the videos where you cannot see the clap, you will hear it, and then you can use the audio track from that video to link everything up. Especially with video, but really with any kind of recording, you need to make sure that you ensure this, the users, that data gets handled only according to a previously agreed upon protocol, confidentially. Usually you never share individual user recordings, of course, without their consent. You usually only use it in internal meetings. You don't share it with anybody outside your design team. And you make sure that the user knows about these plans that you have with the video, and that they agree to it before, usually with a little bit of a written agreement. Not entirely unlike what you guys see when you sign up the Declaration of Compliance, where it also, I think, mentions a couple of things about the video audio sharing. Still, there's a challenge, of course, whenever people get recorded this way, they will feel, especially under test, right? They will feel like they are being tested, not the system. So that's something that you need to be aware of, and you need to put them at ease. We're going to talk about that question on how to handle testers in just a minute. Here's a short video. This is a software that friends of mine at the University of San Diego have developed that has been around for a couple of years. And that's actually a surprisingly useful tool to work with many streams of events, because you may have, you know, keyboard logs on your computer, and you have like the video recording, and you've got an audio recording. Maybe it's a mobile setting and you've got GPS location data or something. And we're going to see how you can synchronize these different things and work with them. The software was specifically developed to work with these many media streams in video analysis for usability studies. So let me roll that video.
Chronoviz is a new tool to support visualization, navigation, and analysis of multiple streams of time-coded data. Advances in technology have given today's researchers the ability to collect many sources of data about real-world activity. While this has great potential to answer scientific questions in new ways, it also presents a clear challenge of analyzing this data. A common example is video. Many researchers conduct research by systematic analysis of video of activity. This is often a tedious process of recording time-coded annotations about the activity that is seen in the video. However, in addition to video, it is becoming common to record several diverse sources of information. More and more types of activity are mediated by digital systems that can be instrumented to record logs of activity, and small sensors can be used to record information about the environment and the research subjects, including movement, position, and physiological data. Although digital recording is becoming more common, many researchers still rely on handwritten notes on paper. These notes may be taken during observation, and may be relied on throughout the analysis process. To support research with these diverse data streams, we developed Chronoviz, a tool to support visualization and analysis of time-coded data, as well as integrate with paper-based note-taking practices. Chronoviz can be used to visualize annotations on multiple time-synchronized streams of data, including multiple sources of video, simulator logs, sensor data, and notes taken on paper with a live scribe digital pen, which records timestamps for each stroke of the pen. Here, we use Chronoviz to support analysis of data recorded from a flight simulator. For this simulator session, the researchers recorded 2 angles of video, a stream of data from the simulator, and paper-based digital notes. The timeline below the video shows 3 tiers of annotations about the activity that is seen in 2 time-synchronized videos. These annotations are color-coded by category and displayed in different rows.
Okay, so as you can see, this is a fairly involved software, and it's also a fairly involved task. Analyzing video, our PhD students can tell you stories about that. That's a time-consuming task, but something that you often need to do to really understand what's going on in the interaction with the system that you're developing. Okay, so that's the qualitative techniques with users, where we basically get questions answered, why questions or what happens. And now we're going to get to the last part, which is the quantitative studies with users that are essentially controlled interviews, right? So these are empirical methods that will give you guys a fond memory of your early statistics classes that you took as part of your training here at RWTH, hopefully. Because here we want to really often understand the cause of a situation or set of events. Like, we want to understand why, is X responsible for Y, right? Are users faster interacting with linear menus than pie menus, right? Those kinds of questions. So you directly manipulate and control certain variables, like the type of menu would be a variable, and then you see whether there is a change. Note that just because 2 things correlate does not necessarily mean that they are causally linked, right? This is a common misconception among statistics newbies, and something that leads to no end of confusion in popular media, right? For example, here is a plot showing the average time that people play computer games in hours per week. And on the y-axis, we've got the average typing speed of these people. Now, if you see that, if you published it that way, you could say, oh, clearly playing more video games will speed up my typing speed, right? That's what this seems to suggest. But that is not at all what this may mean, right? It could also mean, do more typing and it will lead to you playing more games, which is kind of weird as well. Or maybe a more likely explanation could be those who type well on a computer are also people who tend to like playing computer games, so they spend more time playing them, right? Or it could also be that there's a hidden factor here that we don't know about that influences both of these things. For example, those who are fast at reading are, first of all, faster at typing, and secondly, also tend to spend more time playing computer games. So there would be a third factor, that, like a hidden factor, that controls both of these. And we're not, there's no causal relationship between these 2 at all. So careful with correlation versus causation. But we use controlled experiments in which we actually try to determine whether one thing causes the change of something else by carefully controlling our experiments. That's why they're called controlled experiments. And thereby we verify an observation or maybe an existing correlation that we've seen, or just a hunch that we have, that we think, I think there's something going on. How do you do a controlled experiment? Well, you formulate a hypothesis, you design an experiment, you pick your variable, parameters, you pick your fixed parameters. You run a pilot study to debug your experiment, basically. You then choose and recruit your subjects, your participants, your users, and you run the experiment, and then you analyze the data that you collected, you interpret the results, and you then can accept or reject the hypothesis that you had. And as an example, this hypothesis could be something like, I think pie menus are faster to select than circular menus on a typical laptop computer application. Let's look at these steps in a bit more detail. Formulating the hypothesis means when you have something like this, selecting menu items is faster with pie menus than with linear menus, you've now stated something that you can actually verify, right? You have a claim that could be true or false, right? And you're trying to show that it's true. What you then need to do is you need to design an experiment, right? So you need to find the variables and fixed parameters. In this case, you would, for example, take the menu type and say, that's my parameter that I'm going to change, my independent variable. And I'm going to measure the time it takes people to select a target, to seek it, basically to find and select it. And that's my independent variable that I'm going to measure. Then you run a pilot study. Like the DIA cycle, you iterate before you do the real experiment, because you don't want to burn 100 users with your experiment and then discover that you forgot to measure an important variable, for example. So you debug your experiment, right? Or maybe there is something in your experimental setup that biases people towards a certain behavior, or something else, an external factor that's an influence. Maybe there's a phone in the lab that keeps ringing, and you want to just debug things in that way before you run the big study and use up your user base, your subjects. Once you fix that, maybe you've had to improve the distribution of your menu targets to make it less biased, whatever it might be. And then you go into recruiting your subjects. For example, a lot of times, I think in research studies, the subjects are undergraduate computer scientists, right? Or psychology students that just happen to be around, right? Somebody once said that the best studied population on Earth are undergraduate psychology students. Because they're always being used as test subjects in any kind of study that researchers need to run. What I'm describing here, this pi versus linear, is actually a simplified version of a study that Callahan and his colleagues did and published at Hci in 1988, right? So this is an old question that has long been answered, or at least studied in a lot of detail. Back in '88, the people that were being selected were, for example, had consistently little or no experience with using a mouse. I think finding those people today would be super hard. So your test subjects today would be different from the test subjects these people had in 1988, quite likely, which may actually change the result if you were to rerun the experiment, right? Now you run the experiment. So, for example, each participant performs a menu selection, maybe 10 times for each type of menu, 10 times select an item, and you measure the time it takes people to do that, starting from a common starting point so that there's no influence of the starting point on the result. And then you need to interpret the results. And you need to interpret the results to either accept or reject the hypothesis. So for example, the results may be something like you find that the mean, so the average on your seek times is 2.26 seconds for the pie menu versus 2.64 seconds for the linear menu. And also, you may find, we can't tell from just these two numbers, of course, but if you know what the statistical distributions are of these two results, because not everybody is going to be exactly at 2.26 seconds, of course, it's going to be a distribution, a little Gaussian curve. And if these curves are significantly far apart from each other, we can show that the difference is actually statistically significant. And we show that by measuring a p-value. And if that p-value lies under a certain threshold, then we know, well, what the p-value means is basically it is a low p-value means it's extremely unlikely that what we observed was a result that happened by accident. Right? There's still a small chance that our results happened by accident, but it's incredibly small. That's what the p-value tells you. And so with that finding, then you know that you have then been able to accept the hypothesis that actually there is a difference in pi versus linear menus. You've shown in this case that the pi menus are faster than linear menus, significantly faster, as we say in statistics. But if that hadn't happened, you could not say that you know for sure that they are equally fast. It may be that you just didn't use enough users to find the difference, right? So be careful. Rejecting the hypothesis doesn't mean that you proved the opposite. Couple words on controlled experiments. First of all, your subjects. If you are studying something like what we just described, this pi versus linear menu, and you're doing this for a software that's supposed to be used by elderly patients in care facilities to select their lunch options for the week, then you don't want to run the study with undergraduate computer science students, right? Because then your actual users are not going to be similar in their profile, age, education, computer expertise of the particular domain you're talking about, system knowledge, and so on. So you want to make sure that you get this your test users to be similar to your actual users that you are designing for. You also want to make sure that you use at least 10 subjects. Everybody's got different numbers on this. In the end, you can compute certain numbers that you need for a particular level of statistical significance to work. But 10 is a good number, a rule of thumb. You need more people. The more users you have, the finer differences or details you can measure, right? If I just wanted, the difference I just saw was significant because the number of users and the results of the two curves were sort of significantly different from each other. And statistical power analysis is what you typically do that can tell you the exact number that you will need to get a reliable result for your question. We also do these controlled experiments because we want to understand that we want to measure whether something is actually true. It's often not enough to ask people. For example, there's a famous example when Bruce Tognazini, one of the designers of the original Macintosh, ran studies with people trying to measure whether the mouse or a keyboard shortcut were faster, where a lot of people said back then that they found the keyboard faster, but as an experimental result, the mouse was actually faster. But it felt different to them, maybe because the mind was more occupied and didn't notice the passage of time when they were figuring out the keyboard shortcut. This was because they probably had to, actually move from the mouse to the keyboard and then back to trigger the keyboard shortcut. This was not supposed to be a two-handed interface. Okay, so I already mentioned that there are independent and dependent variables, IVs and DVs. The independent ones are the ones that you actually control, right? You change them around, for example, the number of menu entries or the type of menu, like pi versus linear. Each level of an independent variable is called a treatment. So if I only ran an experiment with 10 menu entries, once with a pi menu and once with a linear menu, and then I have people select stuff from this like 50 times, then I would only have two treatments, pi and linear. But if I do this with like 3, 8, and 11 menu entries to get a little bit of a more distribution there, then I would have more different treatments. 3 treatments for the variable of number of menu items, 2 treatments for the type of menu. Dependent variables are the ones that you measure, like execution time is a very a favorite one. Error rates, how many mistakes do people make, or also subjective preferences. And that's interesting because a lot of people get quantitative and qualitative wrong. it's not that quantitative is only what you observe and qualitative is only what you ask. That's not true. Both can be both ways. For example, in a controlled experiment, you usually observe and measure and observe behavior of a user, for example, their reaction time or their task completion time or their error rate. But you can also ask them to rank the techniques that they've tried out by preference. And if you have enough people, that ranking will also give you statistical data that you can quantitatively process. And for example, in the end, claim that people prefer technique A over technique B by a significant margin. Whereas if you ask people, then you usually are getting back qualitative results, right? But in this example I just gave, you could also have them, if they rank the techniques, that could also be a quantitative result. So asking and observing is not the same as qualitative versus quantitative. Just be aware of that. Okay, I know this is a lot of stuff, so we're gonna do a little bit of an in-class exercise to get you guys used to this. First question. We're going to do these one by one and just maybe hear some examples from you guys. You have a study A that investigates whether people who have attended a security training program generate and use more secure. Oh, sorry. Did you say something? Oh, yeah, go ahead. We're going to give everybody.
Sondern deinen hier vielleicht. Ich überlege nämlich, ob es nämlich das Problem ist, das Ladegerät abstürzt. Weil der hat keine Batterie.
Okay, I'm not sure. Does anybody know who's talking, Ollie?
I think it wasn't for us and I muted him.
All right, okay, wonderful. Maybe that was his lunch order, I don't know. Anyway, so we've got a study that looks at, do people who have attended a security training generate and use more secure passwords than those who haven't received any security training? That's the challenge. So now, what would be the independent variable and what would be the dependent variable? Just think about this for a few seconds, and then we're going to ask somebody to come up with an answer. But I want everybody to just consider this for a minute and just think it through. Yeah, Fabian, go ahead. Fabian R.
You would measure the password security, and the thing that's changing is whether the person took a security training or not.
Exactly, right. So the independent variable is training, and it can either be yes or no. And the dependent variable is, for example, the security of the password, the security level of the password that people created. Or you could also maybe look at many passwords that they create and try to bin them into secure and insecure. So we still need to figure a few things out about this, but those are the independent and dependent variables. So that's not hard. Let's do number B. A research team examining the effectiveness of joysticks and trackballs for selecting static and moving targets. That's your setting. What's the independent variable?
I think that static and moving targets are independent variables, so we can control them. And the effectiveness of joystick is a dependent variable that we will measure.
Yes. But there's another independent variable in there, which is actually probably the more crucial one that we're interested in.
You mean joystick and trackballs, like different types.
Right. So joystick versus trackball. So the device is the first independent variable and has a treatment joystick and a treatment trackball. And then because we want our study to not just look at one application scenario, if you want, we are doing targets that are static and moving. And so that's a second independent variable. But you could say it's a secondary independent variable. It's not the original one that we are mostly caring about. It's rather one that we introduce to make our analysis a little more broad and at the same time focused on different things and not throwing everything into one bin. So that later on we can maybe see, oh, joysticks are much faster for static targets, but maybe not for moving targets. But that's the kind of idea behind what we're doing here. And yeah, and the effectiveness is our dependent variable. But how do you measure effectiveness? That sounds very sort of, you know, hand wavy. Any ideas how to improve on that? Victor, maybe if you want to continue this one.
Maybe for some speed measurement, like for, as you showed us in the beginning of this lecture, that you improved also like on the phones, and you measured the speed there. So it's also related to effectiveness.
Right. Oh, and we had a whole burst of activity here. 3 people raised their hand. Yes, so speed is the measurement that you can do. Other idea for that, maybe? Christina, I think you had your hand up as well.
Yeah, maybe it's just the selecting time. So how fast someone can select something, or it's just, yeah, it's maybe just how hard they have to concentrate. But I think it's very hard to measure this. But maybe this might be also an idea to measure.
Yeah, that's a good point. I didn't even think about that one. But yeah, there are measurements in which we can ask people about their mental load during a task, and you could also measure that. So speed would be one thing, mental load would be another one. Jona, maybe another one?
Maybe also the accuracy of hitting the target.
Absolutely, yeah. So speed and accuracy are typical candidates for measuring that. Okay, Kaya, anything else?
Yes, maybe the amount of targets which were hidden in a specific time, maybe. So,
yeah. Oh, actually, it's interesting. When one person said speed, the other one said how much time it takes to hit one target, or you're saying how many targets get hit in a certain time. Those are all the same, right? In the end, they're all measuring the speed with which people are using the device. But you're right, you could have different ways of measuring the speed, and that would depend a bit on what you think is a natural way of doing that, what a natural way of doing that task would be. Great. So let's move on to the third one here. We've got a research team that examines whether virtual teams who use video instant messaging are more productive than teams who use text-only instant messaging. First of all, what will be the independent variables? What will be the dependent variables? And do you have some levels of especially the independent variables?
I think the independent variables are the teams that are using either instant messaging or text-only messaging, or what was it? Yeah, and the dependent variable is the productivity. And I would suggest to measure it either by counting the number of activities that they achieved in a specific time frame, or probably also the accuracy again on how well they did and how well they're communicating or something.
Yeah, or something. Yeah, there's a bit of hand waving that's going on, right? This is getting tricky to measure for sure. But there's actually a technique that counts like the number of distinct ideas that are being generated, for example, in a meeting. So that like in a brainstorming session, this could be an example of a measurement. Or Fabian, you got another suggestion? Fabian L.
I think my hand was just raised from before.
Yeah, I caught you with your hand up in the air. All right, yeah. It's funny, I'm always trying to imagine how that would happen in real life, where people are like holding up their hand for 5 minutes and forget to take it down. Anyway, okay, so you get the idea, right? This is how this kind of works. Now we've got the variables identified. Now we need to come up with a hypothesis, right? So a hypothesis actually predicts the outcome of an experiment. And usually the hypothesis will claim that changing the independent variables, or a variable if it's only one, has an influence on the dependent variables. That's typically your hypothesis, right? And the goal of your experiment is to confirm this hypothesis. We often call this H1, the research hypothesis, the positively formulated research hypothesis. But as Albert Einstein already said, no amount of experimentation can ever prove me right, but a single experiment can prove me wrong, right? So the problem is that we cannot directly prove the hypothesis. What we do instead is we try to reject the null hypothesis, H0, which is sort of the inverse of the original hypothesis. And sometimes formulating the null hypothesis isn't quite trivial, but in general, it's turning around, saying if the research hypothesis is true, then the null hypothesis would be false. Because if we can determine that H0 is wrong or false, then we can accept, in a naive view at least, that the actual research hypothesis H1 is true. And H0 is usually a precise statement, so we will know the probability that it is incorrect. And thereby, for example, if we say that we believe that gaming has, if H1 was, that there is a difference in words per minute between gamers and non-gamers, we could say the null hypothesis is that there is no difference. The words per minute between gamers and non-gamers are equal. That would be the null hypothesis. And then you measure things and you get a result. And let's say you get two, Gaussian curves and they're slightly apart from each other. And then you can determine the likelihood that the inverse hypothesis, the null hypothesis, is still true with these slightly, set apart Gaussian curves. And that likelihood is probably going to be pretty low. So that tells you that the likelihood that your research hypothesis is true is pretty high. That's kind of the take we do on this. Just be sure that if you are unable to reject H0, sorry, that's a double negation, but we need to go do this now. So H0 is the inverse of the original hypothesis, right? We are aiming to reject it so that we can accept our original hypothesis. If we fail to reject H0, it does not imply that you can automatically accept H1. This should say H1 by there on Ollie on the slide there. That's the typo.
Oh, yes.
Right. No, wait a minute. Being unable to reject H0. No, sorry, it's correct. It's correct. I got confused myself. It is H0. Being unable to reject H0 doesn't mean that you can automatically accept it. What I mean by this is if you try to show that there's a difference between gamers and non-gamers in words per minute, your H0 is they perform the same, and you're now unable to reject it. It doesn't automatically mean that it is true. For example, you may just have had a number of participants that's too small. I think I already talked about this earlier on, right? When you have you run a study and you don't find a difference in a significant difference between people, that may be because everybody performs the same, or it may be because everybody performs differently, but there is a lot of variance between the two user groups that you have. They both perform very differently, but the variance is very big, and you don't get a proper Gaussian curve and with enough statistical power yet to actually show the difference. So just be aware that that we have not shown anything really if rejecting the null hypothesis doesn't work. All right, let's do this in-class exercise one more time here. So we need a research hypothesis and a null hypothesis for our scenarios, right? The first one is the study with a security training program. We already said that we have independent variables and have people taking a training or not. And we know that the dependent variables are going to be the security level of passwords used or the number of secure passwords versus the number of insecure passwords, if you wanted to classify them that way. Let's say we go with the security level of the password, right? We can measure that, and there's ways to predict the security level of passwords. So what would be our H1, our research hypothesis? It's not super complex. It's just a little more concrete than we were before, right? With this one. Fabian, go ahead.
Our research hypothesis would be that there would be a significant difference in the security of the passwords between people who took security training and those who did not.
Yes and no. That's a possible hypothesis, but if you look at the question or the question we asked,
it's more secure. Yeah,
more,
not only different.
Exactly. Right. So we are actually saying that the average security level of passwords of people trained is higher, significantly higher than the one of those who don't get the training. Right. And what would then be H0? Do you want to continue that one, Fabian?
Sure. H0 would be that that the passwords are not more secure. So they're either the same or less secure.
Right. Okay, good. Moving to the second one, B, we've got a research team examining the effectiveness of joysticks and trackballs for selecting static and moving targets. We know that the independent variable A is here joysticks and trackballs. The second one is the static versus moving targets. And we've got as dependent variables, we said we're going to measure effectiveness indirectly, for example, by speed or accuracy of selection. So what's a possible H1 here? As we can see here, this is not quite formulated the same way as the last one. Yeah, Julia, go ahead.
I'm not sure, but maybe it could be that we assume that one of the two devices, joystick or trackball, is more effective than the other when selecting static and moving targets.
Mm-hmm. In this case, you could even say, I'm just making H1 is just, I just want to show that there is a difference, right? That could be a claim. But you could also say, for example, joysticks can catch moving and static targets faster than trackballs. Right? That's also a way to do it. Or you could even just have a, you could even just have a claim that says, in general, overall, I expect joysticks to be faster to select targets than trackballs, for example. And depending on how you choose your hypothesis, the more powerful you choose your hypothesis, the more powerful your statement is that you claim as a hypothesis, the more people are going to get value out of your result if you manage to prove it, but also the harder it's going to be to prove, right? For example, if I just say there is a difference, then that may be easier to prove than already claiming that I know which one is faster, but also just knowing that there is a difference isn't quite as strong as the other claim. All right, and then H0 would be, of course, like no speed difference between the two. Plus also in this case, be aware, once I run this study, I may very well find that it is different for moving and static targets. That may happen, right? And then I need to go in and do a more detailed analysis of this data to determine, okay, maybe the trackball was faster for moving targets and the joystick was faster for static targets. Maybe that's what I get. And then if I do get that, I need to do an analysis and draw out these findings and then say, okay, I wasn't able to show my original hypothesis. Instead, I'm getting this kind of more diverse look on data. And then I may have to run more follow-up studies to dig deeper into what I'm discovering. This often happens, right? People run a study and they get a result that doesn't quite clearly, tell them what they were trying to tell originally, but then, they find, oh, maybe this is a variable that we need to pay more attention to. For example, for years, people tried to show, discuss whether reading on a computer screen was faster or slower than reading on paper. And the first studies clearly showed, okay, paper was, was faster. But then somebody said, well, it's actually not the computer per se, but it's the fact that, the display is in green on black rather than black on white. So they redid it with a black and white study, and then they found something else. And then they said, okay, so it looks like resolution of the screen also has an impact. So if we change that, so you basically keep asking the same question, but you find more and more variables that bring you closer to the actual truth, right? Gets you closer to the actual cause of the differences. So that's a typical process in research, that you just keep asking these questions, and your questions become better and better and more refined and more clear, and you learn more about the causal relationships as you go along. All right, let's do the third one real quick. Research team examining virtual teams versus virtual teams using video versus text-only instant messaging. What would be a hypothesis in that third one? Yeah, Aparna, go ahead.
The H1 would be that the virtual teams that use video instant messaging are more productive than the text-only messaging.
Mm-hmm.
And the null hypothesis can be that they are less productive or they are equally productive. There is no difference.
Mm-hmm. Yeah. Okay. So we would have to then still be a little bit more precise in the hypothesis to say we already use one of those sort of variables that we can actually measure. Like, for example, average number of ideas is higher, for example, in the team with video messaging than the one with text messaging, right? You could set out with that, because that's something you could actually then measure in your experiment. All right. So now there are two different fundamental designs of your basic experiment. And sorry, this is a lot of statistic stuff and psychology stuff, but you really need these to get your experiments set up properly, whether it's for your thesis in a research context or whether it's in industrial environments, if you do run a controlled experiment there. The first design is between groups. What that means is you got a bunch of people that do, for example, the pie menu condition, and some other group of people that does the linear menu condition. So each subject only does one variant of the experiment, right? One variant of it. And that means you have at least two groups. And what that does, it isolates the effects of your manipulation. You have a control group that does the normal thing, you could say, and a treatment group in which you change the variable. So linear menus being sort of the standard way of doing things could be your control group, and the treatment group would be one in which you change the linear menus against pi menus, for example. Or with the security training, your control group would be the one that doesn't get security training, and the treatment group the one that does. Now, the big advantage of that is, since everybody who's in the experiment only gets to do either one or the other condition, you don't have a learning effect, right? They don't do the same task twice, once with and without, once without, and learn while that's going on. So that's great for tasks that are very simple, that involve limited cognitive processes, like tapping targets or dragging icons around on the screen, or visually searching a particular shape among other shapes. You know, that kind of stuff, these between group designs are pretty good for. Why? Because there tend to be, as we said before, fairly limited differences in these abilities among people, which we can see by looking at things like Fitts' law, for example, right? These performances are kind of known and are not varying widely among people. So it's okay to split up the group, but you need, of course, twice as many users, right? Because you've just split your user base in half and only have half the number of users for each condition, which for your statistical power is bad, right? You can't show things with equal statistical power at that moment. And of course, there's a danger, especially if the tasks are of higher cognitive levels. If you ask people, for example, to do brainstorming, right? It could just happen if I did this right now with you guys, and I just took the list of participants and split it in the middle, and it's sorted by, by first name initials here. Maybe all the people who have initials from A to K are just the really smart people, and everybody who's got a first name initial from L on downwards are the really stupid people, right? which I tend to agree to because my first initial is J. So clearly those are the smart people. But if by any chance that happened, then I would be in trouble, right? Because then I would get results that aren't actually true because my two user groups were not comparable. The example I usually use when we are really in class and in one room, and people are sitting either near the window side of the room or near away from the window, you could say maybe if I split the room in half, then maybe people who are bright tend to get drawn towards the window light. Bright people like bright sun, and kind of like the stupid people are back in the shadows. And then again, my two groups of students would be different, but I wouldn't know that ahead of time if I didn't pay attention to it, and then I would get results that suggest a difference, but the difference is really in the two user groups and not in the two conditions. So that's a challenge of between groups design. Within groups design is the other one, and I guarantee you're going to mess up these two terms. So try to get them right? Try to pay a few minutes to learn them. They're just difficult to remember correctly. Within groups design means that each subject does all the variants of the experiment, right? So you need not split your user base in half. You only have one user base that does all the treatments. With the huge advantage, of course, that if you have a couple really stupid people in your group and a couple really smart people in your group or whatever, individual differences just cancel themselves out, right? Because they all do all conditions. This is typically what you go for a little bit more complex tasks like typing, reading, or composing text, problem solving, those kinds of things. The disadvantage of that solution, of course, is that you may get learning effects, right? If the task is like, solve that crossword puzzle once on a computer and once on a piece of paper with a pencil, and it's the same crossword puzzle both times, you're going to be faster the second time around, right? So that's a bad experimental design. In this case, you often need to either slightly vary the experiment condition, like for example, use two crossword puzzles that are similarly difficulty, but are different, or you can do a bunch of things to avoid learning effects in other ways. And we're going to talk about those in a minute. Maybe for this is going to be the last thing we do today, and then we're going to wrap up so that we don't go over time too much here. For the experimental designs, let's just look at these three examples. So first example, what are you going to pick? Between groups or within groups? First one, study investigating whether people who have attended a security training and so on. So would you use a between group study here or a within groups study? Yeah, Kaya, go ahead.
I would choose a between groups design.
Why?
Well, because I want to know if there is a difference between users who have the security lesson and the ones without.
Right. So usually you would do a between group study here. I completely agree, because the learning effects of the training are something that you cannot undo, right? You could also consider measuring password security of people before, then let them take the security training and then measure password security again. That would be another way of doing it. But in general, normally, if you want everything to be tested at the same time, you would have to do a between groups version. Number two, examining the effectiveness of joysticks and trackballs for selecting static and moving targets.
I would do within group design, since they can just switch between joystick and trackballs and do all the things, and there we eliminate factors of having already used a joystick or a trackball, for example.
Yes, you could do that. Although you could also go with a between group here because it's a fairly low cognitive task, low level cognitive task, right? Selecting targets. I wouldn't expect significant differences across my user base. So it would probably be safe to use a between group study here. With the advantage that you don't need to worry about learning effects of you. Let's say it's kind of like a game that you let people play, right, to select these targets. there may be a learning effect in using that game or understanding how to play it most effectively. And if you do between groups, you avoid that learning effect having any effect. So you don't need to think about that so much. Matthias?
Can't we have our participants fill out a survey regarding their knowledge in joysticks and trackballs?
That would probably be a good idea anyway, because you want to understand whether you have people who have already used one or the other device a lot, right? Because that would skew your results. Somebody who's already used the joystick a lot would probably be doing much better in the joystick condition than somebody who hasn't used it. So that's a good point. I totally agree. But it would not be enough to solve the between group versus within group question. That's something you should be doing anyway, and make sure that you ideally have a user base who, for example, who've all used joysticks and trackballs to a similar level, all complete newbies under it, or they all have used it a lot, for example. Just to make sure that this doesn't skew your results. You don't want these kind of external factors, mess with your independent variables. And then there's the third one, the virtual teams with video messaging versus text messaging. What kind of study would we do there? Yeah, Julia.
I think I would take between groups, but because somehow if it's like about productivity and doing tasks, maybe it's also a big learning effect when you do the tasks again in the second round with another with the text only version. I think it would be a huge learning effect, so I would go with between groups to eliminate that maybe.
Yeah, so it's a big challenge here, because first of all, you're right. If you give people the same task, like the task is come up with 100 ideas for I don't know, an internet connected toothbrush, then there's no way to do that once with video messaging session and then do the same task again in a text messaging. That wouldn't make any sense at all. So you'd have a huge learning effect. So you would need to change. If you were to go with a within group design, you would certainly have to make sure that the tasks are of equal complexity but different. For example, we once did a programming task with users in which we gave them code to debug, and we used 2 different programs, and we hid some bugs in there that were similar of complexity and similar in number, but they were different bugs. And so that way we ensured that the task was not going to have a learning effect just in the task. However, when you say between groups, then I would be nervous here, because this question of productivity is a very high level cognitive task. And so I would probably vote for a within groups design here, because the performance differences in individuals are going to be huge in this level of an interaction, so that you want a design that cancels these things out. Yeah, Julia, go ahead.
So maybe I would, check what type of tasks I would take for my survey. So maybe if I have like complex tasks, then I would go with your version, and if they are simple tasks, maybe then in between, like the between groups version.
Yeah, exactly, and that's exactly the idea. And I guess the question of productivity in a team, we were considering to be something that is around brainstorming or solving riddles or what. Anyway, it's going to be probably rather high on the cognitive complexity scale, and that would then, as you say, would rather suggest a within groups design, with all the challenges of learning effects that we need to then take care of. And we're going to have more slides on that and more content on how you deal with with these learning effects, these order effects, as we call them more generally, because it's not always just that you get better towards the end of the experiment. Sometimes it's the opposite, like when you get tired, for example. So we're going to talk about how we can balance these things out when we have within groups designs. But that will be something for another time. For today, we're going to wrap this up. Thanks to everybody for listening in, for participating, and I'll see you again next time. Bye.
This content was provided by RWTH Aachen University.